Okay, folks, I know there's a few of you still trickling in, but we're going to go ahead and get started. It's great to see so many people here today. My name is Chris Derr, and I am really happy to be here today to talk to you about something that I have a lot of passion for, and that is mixed reality experiences. I run the Holographic Academy at Microsoft. The Holographic Academy is chartered to train developers and designers on how to create great holographic experiences. And I'm guessing there's a few of you in the room that are developers and designers. So today I would like to take you on a short journey, a short outline of what it takes to become a holographic developer. Now, I have a big passion for books such as science fiction books such as Neuromancer, Snow Crash, Ready Player One, and probably some of you in the room here have read some of those books. And they paint a world in which you're able to leave the physical environment and enter a fully digital or immersive environment, virtual reality. And so the notion of virtual reality has been with us for some time. But what do we mean by mixed reality? Mixed reality is often thought of as an intersection point between the physical world and the digital world. And for the most part, that is true. But we shouldn't be thinking of mixed reality as a point. Rather, mixed reality is a spectrum. If we think of our experiences or our applications as a storyboard, that storyboard is composed of a bunch of frames or scenarios. And each frame in that story exists on this spectrum. Dial it to the left, and you're more in the physical world with maybe limited digital content, or maybe no digital content. Dial it to the right, and you're immersed in a more virtual reality world. Every frame in that application, in that story, has its own position on this spectrum. The story itself is composed of environments, objects, and humans. And those factors also exist on this spectrum. For example, today in this room, all of us, all the attendees, are in a physical form. However, we can imagine a time in the not-too-distant future where some of us are represented as avatars, in which case we would dial the scenario more towards the right. As developers and designers, we have to pay special attention to the relationship between the environments, objects, and humans in both their physical and their digital form. If that relationship is in harmony, you will create very meaningful and powerful experiences for your users. Let's take a look at an example. Here we have an application that allows two or more people to collaborate on the design of a modern home. In this example, we have Amy and Lane. There are two humans. They are represented both in a physical form and an avatar form. The object of attention is the model home itself, and it's represented in a digital form. And there are two environments. One is in the kitchen, and one is where Amy's located in a conference room. The designers and the developers of this application had to think carefully about the environments, objects, and humans in their scene. For example, how do you represent a human digitally in the scene? How do you capture the authentic nature of the representation and the movements? And if one of those avatars enters the physical person's personal space, is that a violation, and how do you manage that? Intent, focus, and control are really interesting as well. Does Amy know what Lane's looking at? And does Lane understand Amy's intent? And who is in control of what assets in that scene? And then we have an interesting challenge just with the environment. You have a kitchen and a conference room, very different environments. And managing where you place the digital assets and the relationship to physical things such as tables and chairs can be a real challenge and has to be considered very carefully. Now, let's move to the next sequence. This is still the same application. What's interesting here is that Amy has requested that the scene be moved towards a fully immersive environment, in which case they are able to walk around the inside of that digital home, and they can see the view from inside to the outside world. Amy has essentially created a context shift in reality. Now, as developers and designers, we have to think carefully about those context switches. It's really important to ensure that users safely and quickly move from one context and reality to the next. If you don't manage that carefully, you can create a very poor and troublesome user experience. So through this example, I hope you have a little bit better understanding of what we mean by mixed realities and some of the opportunities and challenges that face us. And I'd like to share with you a few more examples from some of our partners that have built applications on HoloLens. From seeing 3D in 3D to hands-free 2D experiences, HoloLens allows us to create and solve problems in exciting new ways. So let's talk about some of the challenges you may hit when you're trying to build a mixed reality experience. In the video, we saw a tool that allowed you to design your own kitchen. This tool is from Lowe's. It allows you to pick holographic tiles and holographic counters and overlay them in an existing kitchen to make choices about your new kitchen design. We also saw Glenn Lynn here as an architect working with Trimble and HoloLens to explore design ideas for the enhancement of the famous and historical Packard building in Detroit. Each of these scenarios require the holograms to sit stable, to look and to be comfortable in viewing. So I think it's really important for us to talk a little bit about how do we make holograms stable and comfortable. In the video, we also saw Volvo's applications. They had a scenario around a sales tool and design tool. Each of these were a collaborative experience. And in fact, almost every commercial application will require or request some level of collaboration, of sharing holograms. So I think today we should also talk about how do you share holograms. And finally, you may be wondering how we even captured those videos or these photos on the screen. Capturing mixed reality is really powerful and important. So let's spend a few moments today talking about that as well. Believability is a core design principle in mixed reality. If I place a holographic can on this table and it jitters or it seems to swim as I move, the effect of believability is lost. The can needs to sit stable and follow the rules of physics. HoloLens does a remarkable job of world-locking holograms. However, a poorly implemented application can create problems. Let's take a look at a couple of videos. On the left, we see the frame jumping around. We see the holograms jittering. It's almost uncomfortable to watch, and it certainly is uncomfortable to watch in a 3D viewing experience. On the right, the application has been corrected. The frame is stable and the holograms move smoothly. We have characterized the problems and have recommended solutions to these issues. Is the hologram jittering, jumping around? Chances are you have not properly implemented your stabilization plane. If you're seeing swim, are you using a world anchor? Now, in 30 minutes, I cannot possibly go into all the details and all the solutions of these problems in these situations. However, I have good news. We have documented how to create and design holographic applications. We have established case studies. This documentation has come from our own developers and designers. So you would be, by reading this documentation, you are effectively learning directly from our own experts. So my first guide in our journey to become better at building Windows holographic experiences is to leverage the documentation that we've developed at the HoloLens team. Now, certainly moving holograms creates discomfort, but eye strain also can create discomfort. We've done extensive research to understand the distance that holograms should be placed in a frame. So this takes me to my second guidepost, which is the videos that we've established and put on our YouTube channel. We have over 30 videos that explain the concepts to create compelling Windows holographic experiences and mixed reality experiences. Let's take a look at one of these videos.
Have you ever gone to a 3D movie and gotten eye strain, a headache, nauseous? Why does this happen? And how does it apply to the world of HoloLens? There are several things going on when you view stereoscopic 3D content, all related to your eyes and how your brain is interpreting what they see. The first factor is accommodation. Accommodation is the ability of your eyes to focus on an object as it changes its distance from you, similar to the way an SLR camera moves. If the camera is focused on the foreground, the background will appear blurred. Conversely, if you focus on the background, the foreground will. Your eyes work in a similar way. The second factor is vergence. As an object moves closer to you, your eyes slowly converge. As the object moves away, your eyes diverge. Lastly, vertical disparity refers to the vertical alignment of the holographic images relative to the user's eyes. If the device is slightly tilted, then each eye is looking at the image at different heights. To bring the images together, one eye strains to look up, while the other strains to look down. When viewing holograms, your visual system gets conflicting distance information on where to focus. Vergence and accommodation are sometimes in conflict, leading to a strain on your eyes. Designers and developers can help make holograms more comfortable. Our research found that holograms are most comfortable at 2 meters. Holograms closer than 1 meter can cause more vergence and accommodation conflict. Distances further than 2 meters cause somewhat less conflict, but you still want to keep most of your content within the zone of comfort. No sets of eyes are the same, and no two experiences are the same on HoloLens. What is comfortable for you may not be comfortable for others. We encourage you to read and follow the guidelines to make sure that the HoloLens experience is enjoyable for everyone.
Okay, let's move on to our next topic here, which is sharing holograms. What a powerful range of scenarios this ability unlocks. Sharing holograms allows us to present, collaborate, and guide in ways never before possible. From the Case Western Medical School educational scenario to PACCAR using HoloLens to design premium semi-trucks, nearly every commercial application will want to take advantage of sharing holograms. Sharing holograms requires us to have an anchor and a coordinate system. Let's take a look at another one of our videos to understand how that works.
Early map makers would start by noting prominent physical or geological features and then fill in details by placing items relative to these markers. As the cartographer explored more and more of an area, the accuracy of the map would improve. HoloLens maps a room in a similar way. Tracking works to recognize surfaces and features of a room. When holograms are world-locked, that is, placed relative to real objects, then the holograms are anchored relative to these surfaces. As the user moves around a room, the details of a room continue to be mapped so that the placement of holograms relative to these surfaces becomes more accurate and solid. Since tracking is more accurate at closer distances, the image the HoloLens has of a room continues to increase in accuracy over time as the user moves and views room objects from various angles. You can even have multiple anchors in a world-locked scenario, with each anchor having its own coordinate system. The holographic APIs help you translate coordinates between the different coordinate systems. As the HoloLens continues to track and get better information about its environment, the translation between these coordinate systems will get more precise. Best of all, this information can be persisted so that the HoloLens knowledge of a room can be retained for the next session or shared with another device. This opens up many possibilities to create imaginary shared worlds.
Okay, so this is all real cool, but sharing holograms does not happen natively on the Windows holographic platform. So how can you get going on creating a shared hologram experience? We have created an open source project and placed it on GitHub called the HoloToolkit. The HoloToolkit has a bunch of components that will help you get going quickly on HoloLens, and one of them is all about sharing holograms. The HoloToolkit contains a lot of other rich components as well. For example, in this photo, you see an avatar sitting on a couch. The digital and the physical world are acting in harmony. So another component we have in the HoloToolkit is all about spatial understanding. That component will allow your application to understand objects in the room. We encourage you to use the HoloToolkit, but we also ask that you contribute to it. Add your own valuable additions to this open source project. All right, so we've got HoloLens, we've got the Windows holographic platform, we've got this HoloToolkit. There's a lot of rich capability in all of that. And so how do you learn how to make those pieces come together in a meaningful way? And that takes us to our fourth guide on this journey, which is the tutorials at the Holographic Academy. We have developed over 9 tutorials that cover the entire gamut of features within the HoloLens platform. Each tutorial is broken down in a way that allows you to work at your own pace. I encourage you to take a look at those tutorials and learn how to use and take advantage of the features in HoloLens. All right. So, you've gone to the documentation, you've watched a few videos now, you've taken some tutorials, and you've built a really amazing experience using the HoloToolkit. Sooner or later, you're going to want to capture that experience. So this brings us to our next discussion point, which is capturing mixed reality experiences. Now, there are many reasons why you may wish to capture a mixed reality experience. For example, you want to publish this really amazing application that you built to the store. You need some high quality photos for your storefront. Or maybe you're hosting an event like Unite and you want to establish a holographic photo booth so people can take photos at the event with their holograms. Your marketing director has come up to you and said, this experience, this application is amazing. We want to create a video around it for the website to generate demand. How are you going to do that? The CEO would like to present your application on stage to a live audience. You now need to figure out how you're going to do a live mixed reality capture. Or you have an idea how to extend your experience so that people that are using 2D screens could also participate and see what's going on inside. All of these are reasons for doing mixed reality capture. Now, there are a couple ways to do it. The most basic way is using the feature we call mixed reality capture, or MRC. MRC is accessed through the device portal. The device portal is a really powerful tool and will give you lots of information around your performance and your system. But it is also the way that you access the mixed reality and the camera built into the system. MRC allows you to take photos and short videos. At a recent hackathon, a developer wanted to show off his version of HoloJenga. He used the MRC to create a short video sequence to share with the other developers. This is really simple and really awesome, but it does have some drawbacks. For example, the image quality is not the highest level, and the camera is actually sitting on your head, so any movement of the camera is going to be captured in your video. So we set out to build a better solution for higher quality mixed reality capture, and we call this solution Spectator View. You can see here a photo of a Spectator View setup. There's a DSLR camera and a HoloLens mounted to the top. Spectator View allows you to capture high-quality, third-person photos and videos, as you can see in this short video sequence that we built through Spectator View. When this project is released, it will be open sourced and on GitHub as well as the mounting system, which you can 3D print and attach to most DSLR type cameras. So this takes me to my fifth guidepost, which is use the HoloLens Companion Kit. The HoloLens Companion Kit is located on our community page alongside the Holo Toolkit. The Companion Kit will include, when released, the Spectator View, but today it also has other tools in it as well, such as a Connect-based project that allows you to quickly calibrate HoloLens devices for retail or demo experiences. It also has a tool in there that we use to manage the deployment of application across multiple devices. And there are other projects that you'll find useful as well. I strongly recommend that you go to the toolkit and become familiar with what's available, as we're constantly adding new ideas as they come aboard. Okay, so we have taken today a short developer journey in mixed reality. I have outlined a few recommendations in terms of what you can do to help yourself become an expert in building window holographic experiences. And so this brings me to my sixth and final and bonus lesson, which is the forums. We are actively engaged in the HoloLens forums, and we invite your participation as well. We are all here today because we want to be part of this transition, and we want to help you with that. We also want to learn from you. Please engage, ask questions, and help others. Thank you so much, and enjoy the rest of your conference today.